Hello, so in this problem, we have three springs hanging from the ceiling. Um, the first spring has nothing attached to it. These three springs are identical. The second spring has a 4.5 Newton block hanging, and the third spring has a block of unknown weight hanging from it. The first question, we need to find the spring constant in newtons per meter, and in the second part we want to find the weight of the block hanging from the third spring. So to address this question, we can recall Hooke's law. We know that the force is equal to the stiffness constant or the spring constant multiplied by the elongation, which we can name x. So the question is to find this spring constant, which can be written as the tension force exerted by the spring divided by the elongation. Now, we know that the tension force here is going to be equal to the weight hanging from the spring, since we have equilibrium. So the tension force will be equal to the weight, and we know that the weight has a magnitude of 4.5 newtons for the second spring. In the first situation, no forces exist here on the spring. There is no tension exerted by the spring and no hanging mass to exert a weight force or an applied force on the spring. So here obviously x is equal to 0, the elongation of the spring is 0, but we can also say that the length of the spring here is equal to L0, which is the natural length of the spring. So we can see obviously here that the natural length is 20 centimeters. So this can be useful later, or if we want to calculate the elongation actually. So to find the spring constant, we look at the second situation, since we have the values of the weight force, and we can just say that this is equal to the tension like we said. So this force here is going to be equal to 4.5 newtons. We still need the elongation in order to find the spring constant. We know that the elongation is equal to L minus L0, the new length of the spring, minus the natural length of the spring. And from the figure, we can see that in this situation, L is equal to 35 centimeters. So we just substitute here now the value of the force, the length of the spring, which is here 35 centimeters, and I will change this to meters because we want K in newtons per meter. We found L0 from the situation where nothing is hanging to the spring. So this is 0.2 meters. And we can now find the spring constant. And if we calculate this, we will get 13 newtons per meters. So this was part A. In part B, we want to find this unknown weight here. So if we want this weight, we know that this weight, which is pulling downwards, is going to be equal to the tension exerted by the spring here. So if we can find the tension, it would be just equal to the weight of the block hanging from the spring. So we know that W is equal to F because the spring is in equilibrium. And we know that F is equal to K times X, and X is L minus L0. We just found K in the previous part, it's 30. And we can find L from the ruler that we have here. L is equal to 50 centimeters for the third spring, which is 0.5 meters. And L0 is the natural length of the spring, like we said, which is 20 centimeters or 0.2 meters. So this gives us 30 times 0.3, and the value of the weight here is going to be 9 newtons. So in this question, we just applied Hooke's law in order to find different variables for hanging masses that are elongating a spring.